good morning or good afternoon. Hopefully you guys are having a great day so far. Hoping to be back tomorrow, but it kind of just depends on how my husband is doing. So first thing, if you guys want to make sure you have out your calculators, it doesn't matter if it's scientific or graphing. I eventually do think that graphing is a little bit nicer to use down the road. And so far, we've been working with logs, just everything by hand, and we haven't really used our calculator for anything. So we're going to do our best with, since I can't really visually show it to you guys, but if you look along the left-hand side of your graphing calculator, you should see the word log. And we've talked a little bit about this already, but your calculator is in base 10. And that's why you don't see a base below it, because it's already in base 10. Okay, so go ahead and I want you guys to just type log 7 and see what that comes out to be. Okay, and typically with logs we round to 4 decimal places, so this is going to be 0.8451. Okay, so of course we can't live in this world that every log has a base 10. So what happens when we don't? Okay, so let's say we have this example, log base A of C, and you're going to rewrite this as the division of 2 logs. So you drop the base, and that becomes the denominator, so log A, and then you bring the C up and make this log C. Okay, notice that there aren't numbers here, because what the change of base formula allows us to do, it allows us to change the log into a numerator or a denominator of base 10 and then able to plug it into our calculator. Okay, so biggest thing, sometimes students do confuse which one goes on top or which one goes on bottom. Remember that this is the base of the log, and always drop the base down, drop it to the basement. So depending on the type of calculator that you have, some calculators, when you type the division key, it goes ahead and makes it a fraction for you, and you just type things in the top and type things in the bottom. If your calculator doesn't do that for you, then parentheses are going to be crucial for us, and that's what this little active note is about. Okay, so first thing, this example, we're going to notice that this is not base 10. So we do have to go ahead and apply the change of base formula. So I'm going to drop the 4 and then keep the 25 up. So log 25 over log 4. Okay, and once again, depending on your calculator, you might need to make sure that you close this parenthesis first before you divide. Okay. Go ahead and practice plugging that into your calculator, and we should get 2.3219. Okay. In the next example, notice that we don't see a number written as the log. So then that just means we are working in log base 10, which is known as the common log. So you just can go ahead and plug that into your calculator directly, and you get 1.2304. Okay. All right, and then 4 and 6 are similar to number 2. You just plug it into your calculator the way it is, since it's already in base 10. But I do want to take a look at number 5. So once again, drop the base first. So this becomes log 3, and then in the numerator log 18. A very common mistake here is this is not log 6. Okay, a lot of students will try to divide the 18 over 3 because they try to apply the quotient property of logs. But remember that the quotient property is for when you have log 18 minus log 3, not log 18 divided by log of 3. Okay, so these are not the same. So go ahead and plug that into your calculator. So log 18 divided by log 3, and we should get approximately 2.6309. If you're wondering what those little squiggly symbols are, that means approximation. Okay. All right, so let's move on to how we're going to apply this. Okay, so it says solve each equation, check your solutions, find exact and rounded answers to 4 decimal places. So what those both means exact is still going to have the word log in it. Okay, whereas rounded means you plugged it into calculator and you got a decimal. Okay, now not every answer is going to have a rounded answer for us. Like you'll see in number 1, it doesn't. But the rest of the problems will, so you need to find both exact and rounded. And on your quiz, your future quiz and future test, you'll have to do both as well. Okay, so before you start any problem, this whole concept of look before you leap, look to see if you can change them to be the same base, because you guys have been practicing that already. And notice that we can go ahead and change 27 to be a base of 3. So when it's the same base, we don't need to use logs. So 3 to the x equals 3 to the third. So x equals 3, and you're done with the problem. Okay. Whereas in number 2, notice that these bases are not the same. Okay. And we can't change 120 to be a base of 5, so we're stuck there. So there's 2 different ways you can approach this problem. I like to keep it uniform to what we do in the future with more difficult problems. So I'm going to show you guys both ways, but just know that I'll probably just stick to one way, so that way, like I said, it keeps it uniform. So one way to do this problem, I'm going to zoom in on this. So one way is to rewrite an exponential, which means circle on up, and then apply the change of base formula. Okay. The other way to do this is to just log both sides, and then we can apply the properties of logs in order to solve for the variable. Okay, so both you can do. This is the way that I'm going to primarily do this, due to the fact that that's what works better when we do more complicated problems. Okay, so looking at example 1, there's 2, sorry. Once again, we've already established the fact that we cannot rewrite 120 as the base of 5. And notice that there's a variable in the exponent. So we need something to allow us to get that variable out of the exponent. And going along with number 2 that I wrote down, we can log both sides. Okay? Logging both sides is like the same thing as adding 5 to both sides. Whatever you do to one side of the equation, you do to the other side, and it balances itself out. Okay. Then we can apply one of our properties to get this variable out of the exponent, and we can bring it down in front. So, sorry again. We have x log 5 equals log 120. And then we just go ahead and we solve for the variable. So we're going to divide by log 5 on both sides. Okay, so this would be known as the exact answer. Okay, then plug it into your calculator. So log 120 divided by log 5, and you get approximately 2.9746. This is your rounded answer. Okay, and the other way we could have done this problem, like I said, is applying way number 1, and that's to rewrite this in exponential form. So log base 5 of 120 equals x, and then use the change of base formula, so log 120 over log 5, and notice that these two are exactly the same. Okay, so like I said, it doesn't matter which way you do, and it's just that number 2 I think works better in more complicated problems, so I kind of like just to stick to one method. All right, let's look at number 3. So we definitely can't rewrite 45.6 as a base of 6. So we're going to go ahead and notice that there's a variable in the denominator, so I need to log both sides. Okay. And then we can apply our power property of logs, bring down the x, so we get x log 6. And then from there, just like the previous problem, we just solve for x. Okay. And remember that the exact answer will still have the word logs in it. The rounded answer is when we go ahead and plug that into our calculator. So if you go ahead and do that, you should get approximately 2.1319. All right, let's go to number 4. Notice once again, we can't rewrite 27 as a base of 4. And we can rewrite 4 as 2 to the second, but that doesn't help us at all. And so my next step then would be just to log both sides. And just because there's a 2x as the exponent, that doesn't change what we do. We're going to go ahead and still bring this in front. Okay, and then since I am solving for x, I want to get x by itself, and I can actually go ahead and divide by 2 log 4 at the same time. So then we get x, the exact answer, to be log 27 divided by 2 log 4. Okay. Let's practice plugging that into our calculator. So once again, if you need to close your parentheses, make sure you do. If you have a calculator that makes a division bar for you, go ahead and great. But either way, we should get approximately 1.1887. All right, let's go to number 5. Okay, so once again, different ways you can do this problem. I just like to keep things uniformed, so I'm going to go ahead and log both sides right away. Okay, and once again, I'm going to apply the power property of logs and bring this down. But I've got a really important active note over here. Must use parentheses if you are bringing down an exponent that has addition or subtraction in it. Okay, so I'll say that again, because it definitely comes into play tomorrow with difficult problems. You must use parentheses if your exponent or your power has addition or subtraction in it. So I'm going to go ahead and put parentheses around the x minus 4, and then I have log 2 equals log of 82. Okay. Once again, some of you might notice that you could divide by the log 2 first and then add the 4 over to the other side. That definitely works, but this is going to lead us into tomorrow. So I'm going to do it this way instead. So x log 2 minus 4 log 2 equals log of 82. And then I need to solve for the variable. So I'm going to move the 4 log 2 over to the other side by adding it. Okay. And then I'm going to divide everything by that log 2. Now I know some of you guys like to make up math rules on me, but remember that if you can't complete the heart, everything must stay. Okay, so sometimes students will try to cancel out these log 2's. Well, this log 2, I mean, perfect timing, it's Valentine's Day tomorrow, but this log 2 doesn't have the other side of its heart. It doesn't have the other side of its Valentine. Okay, so you can't cross these out. You leave this the way it is. If you would have done this problem rewriting in an exponential form first and then solving, you would have gotten log 82 over log 2 plus 4 equals x, and both of these will actually get you the same answer. Okay, so we're going to go ahead and plug this in your calculator, and this is very, very important if you do not have a calculator that does a fraction bar for you and makes it look like a fractionary calculator. You need a first parenthesis around this. Then your calculator is going to put a parenthesis for the log, and you need to close it. Parenthesis for the log, need to close it. And then another parenthesis before you divide by log 2. Or one way that I like to do this, that I don't have to worry about parentheses so much, is I'll just go ahead and do this part, hit enter, and then do divide by 2 in my calculator, or divide by log 2 in my calculator. Okay, no matter what, you should get 10.3576. Okay, all right, last problem. If we look at number 6, same thing. We're going to log both sides. Bring down the x squared in front. Okay. Then we need, not sure if you heard that or not, but Wrigley was just shaking for you guys. We're going to go ahead and divide by log 32 from both sides. Okay. And then we still have to get x by itself, so we're going to go ahead and square root both sides. And what do we have to remember? Square roots. Great. Hopefully you said plus or minus. So plus or minus the square root of log 50 over log 30. Okay, that is our exact answer, and we do include plus or minus. Okay, and then we would plug this into our calculator, and we would just get plus or minus 1.0725. Okay, all right, so that's it. Wasn't too bad of a video today. You're gonna have the rest of the time to work on your homework. Please, 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 especially since I'm not there today, help each other out. If you have questions on the calculator, help each other out. You know, that's always a sign of a good group, is when a teacher's not there, you help each other out. All right, so thank you again, and hopefully I will see you guys tomorrow.